All right. So to move on with our study of quadratics, we need to investigate something called the zero-factor theorem. And this is a rather obvious math fact that we don't think about too much, but if we do start thinking about it, we can apply it in a lot of interesting ways. Basically, the theorem is this. If we have some sort of expression where I'm multiplying two things together, so some variable A multiplied by some variable B, and the result of multiplying those things together is 0, then one of two things must be true. Then A is 0, or if it's not, B is 0. In other words, if I have a multiplication that results in 0, one of the two things that I'm multiplying, one of the two factors, has to be 0. I can never get 0 by multiplying two numbers that aren't 0 themselves. 1 times 1 or 5 times 5 or whatever. I'll never get 0 unless one of the two things involved in my multiplication is 0 itself. And hopefully that's kind of intuitively obvious. And we're going to use that in many, many different cases throughout this unit as we study quadratics. Let's look at an example of how that might be useful to us. Let's say that we were asked to take a look at the quadratic equation x squared minus 5x plus 6 is equal to 0. In other words, I want to find what values of x I can plug into this quadratic expression so that I got an answer of 0. Well, that's very difficult to do using the old school style algebra that you learned in grade 9. I can't rearrange this equation in order to get x by itself and solve it that way. Or rather, it's a whole lot of work to do that. So instead, to solve this, rather than trying to get x by itself on one side of the equation, I am going to first factor this thing, and I'll factor it by thinking about two numbers that add together to give me -5 and that multiply together to give me +6, and those numbers are -2 and -3. So that's just the basic quadratic factoring that you guys learned last year and that we practiced on Tuesday. And then once I'm at this part, I can apply my zero-factor theorem. So since I have this times this is equal to 0, I can say that by the zero-factor theorem, one of two things has to be true. Either x minus 2, this guy, has to be equal to 0, or x minus 3 has to be equal to 0. That's how the zero-factor theorem works. I was multiplying two things together.
Carson Schneider to the office, please. Carson Schneider down to the office, please.
Multiplying two things together to get 0, so one of those things must be 0. Now that I've done that, I can treat each of these two equations on its own, and very, very quickly, I can solve for x. Like for this equation, I can add 2 to both sides and get that x equals 2. And for this equation, I can add 3 to both sides and get that x equals 3. Those are the solutions to this original equation. The solutions that x equals 2 or x equals 3. If you tested them out by plugging in 2 or plugging in 3 for x, you would see that they both work. So we were able to solve this equation, and we did it first by factoring, then by applying the zero-factor theorem, giving us two possibilities, and then doing algebra old school with each of those possibilities to end up with a final answer here. And for the first little bit in this quadratics unit, we are going to solve all quadratic equations using the zero-factor theorem in that way. So we will practice with that tomorrow.